Welcome to the class. Today the topic we are going to discuss about transducer. What is transducer? So when you are talking about transducer is a device which is used to convert one form of energy into another form of energy. So in the third unit itself we have come across so many transducers. Generally your transducers is classifying into two types, that is active as well as passive. What is active and passive? So active in the sense which is we call it as it is a self-generating one. So self-generating the sense it doesn't need any power source. But passive it does not like active. Passive transducers will have an external power source. External power source. That was the difference between your active as well as passive transducers. The examples of active transducers are thermocouple, then thermopile, then piezoelectric pickup, then photovoltaic. So thermocouple, which is nothing but, you all know the basic principle of your thermocouple, which is nothing but it is Seebeck effect. Thermopile, which is nothing but a series combination of your thermocouples. Combination of thermocouple. Then piezoelectric, which is nothing but when you are applying a force, you will get an electrical voltage. Then come to passive, you are having I have given some examples: potentiometer, then RTD, thermistor, photoconductive cell. So potentiometer, which is an best example of resistive transducers, RTD, which is resistive temperature detector, then we have a thermistor. Thermistor, which is nothing but it is made up of semiconductor material. Then when you comes under this potentiometer, normally the resistance transducer, we talks about potentiometer. Potentiometer, the main purpose of potentiometer is used for measuring displacement. So the connection is look like this. You have a potential divider, that is what the indication. It consists of three terminals, that is 1, 2 and 3. So you are having three terminals. Accordingly the potentiometer is used to connect. So the working of resistive transducers are R, which is equal to rho L by A. So what is the meaning of your rho? Rho, which is nothing but length of the conductor, A, which is nothing but area of conductor, L, which is nothing but rho is resistivity of conducting material, L is your length of conductor. So when you comes for this potentiometer, there are two different types of potentiometers we have, that is translational as well as rotational. So from the term itself you can understand that your translational, which is nothing but we used to call translation, it is also linear. But when you comes for rotational, the rotational one is, we have an example is helipad. The people used to call helipad. The people used to call rotational as an helipad. So when you are keeping this rotational and the linear one, we have two types that already I told you. Your linear as well as rotational. So when you are combining these two, that is linear as well as rotational, the combination of these two potentiometers are called as an helipad. So helipad will give you the combination of both linear as well as rotational potentiometer. So either you can go for linear or you can go for your rotational potentiometer. So both the things we can use it. So when you comes for this resistive transducer, another one example is strain gauge. You all heard about strain gauge in the previous unit. So strain gauge, which is nothing but it's a conductor. When a force is applied to the strain gauge, there will be two different action. Either this will get compressed, right, or some deformation. So the deformation only either it is because of compression action, or it will be getting some other action. So your strain gauge, the main terms we used to called stress as well as strain. You all know about stress and strain, right? So stress, which is force by area, strain, which is nothing but change in distance by original distance. So we used to call it as a deformation of the length, right? Dimensional change we can call. That is what your strain. So the resistance of a conductor or the semiconductor charge when it is getting strained, that is what your strain gauge we can call. So either you can go for translational, or you can go for your what is it called, rotational. So we have two different types, translational or rotational potentiometer. Either you can go for these two types. The working principle is change in value of resistance. Change in value of resistance with change in length of conductor, right? So that is what the working of your potentiometer. So either you can go for translation or you can go for rotational. So both are working under the principle of R, which is equal to rho L by A. Okay, that was the working nature of the potentiometer. And moreover, the resistivity of the material is also changed when the change in temperature, thus causing a change of resistance. So your resistivity, it is also depends the resistivity of material. That is very, very important. This will also getting changed with the change in temperature. Right? So the resistivity is also getting varied while the change of temperature. Because of this, there will be a change in resistance. Okay, that is what the working. So the same principle only working in your potentiometer as well as your strain gauge. Got it? So here we are talking about potentiometer. So the other name of potentiometer, it is also called as an voltage divider. Maybe you could have gone in the previous classes, voltage divider. So they used to put like this, right? So the voltage divider, the another name of potentiometer. And here we used to call, in the previous diagram I have indicated like this. So this line they used to called as an sliding contact. So whenever the sliding contact of the wiper is getting vary, then there will be a change in resistance. So just I would like to show you the diagram, because this is your input voltage EI, and here this is your wiper. Okay, and the sliding contact we have. Out of this part I am going to calculate the output voltage, that is E0. Suppose I want to measure the value, then I can just connect one meter across this portion, then I can able to calculate the value. Okay, so this is this is what we used to, this one, is xt, and here how much amount of variation it happened, that is xi, and this is your output voltage. So how this output voltage is measured? E naught, which is equal to your input voltage into xi divided by xt. So this is what the output expression in terms of output voltage, input voltage related to the how much variation of your sliding contact. Actually this xt, which is nothing but the total length of the conductor, xi is how much amount of displacement is happening because of this sliding contact. So the output voltage E naught, which is equal to ei into xi divided by xt, and here this is what this portion they used to called as an sliding contact. Okay, so this is how they are measuring, and moreover the motion of your sliding contact, the same, this wiper and the sliding contact. So here the sliding contact motion, how we are saying it is translational or rotational, that is because of your sliding contact movement. So if the sliding contact movement is varying like linear, then we used to call it as translational motion. If the variation is like in circular nature, then we call it as an rotational. Suppose in some application I am in need of both linear movement and the rotational movement, then they will kept as a combination, we get into helipart. Okay, so this is how your potentiometer operation. Okay, so this is how it's working. So one more thing is, when you are talking about like either you are going for translation or your rotation, getting into the motion of sliding contact, either translating or rotational, and the translational resistive elements or the stride devices, right? But when you are going this linear, what was the distance of the wire they have used is 2 millimeter to 0.5 meter. This is for your linear component, and for circular, that is your rotational one, they are using 10 degree to 60 degree. That was the thing they have used. And the main thing is about the material, what type of material the people used to go for. So the people used to go for in the potentiometer materials are like cermet, then we have hot molded carbon. The material used cermet, then hard molded carbon, then we have some metal film. The main thing is about the material. Why? Because the material is very important, because your principle is depends on rho L by A, right? So if the material is not chosen properly, you can't able to identify the resistivity of the particular potentiometer, right? Then when you are talking about the characteristics of this potentiometer, like characteristics, when you are talking about, there are two things, loading and unloading. So loading action means what? Already in the previous class we had a discussion. Loading and unloading, we will get two characteristics. Either it will go linear or this will go into non-linear. So linear means whatever the output you are getting from the potentiometer, E0 by EI as well as Xi by Xt, when you are plotting the graph, maybe like if you are getting like this, there is a proportional change, then this will fall in the nature of your linear graph. If it is not so, that will happen in your unloaded potentiometer. So in the loaded point as well as unloaded potentiometer means I am not loading any particular component or something, like I am not loading anything, then it is unloading. So there is a possibility of in unloading I will be getting a linear relationship. But if you are going for loading, what will happen? The loading point, if the graph will go like this also, that means you are not getting a linear relationship. So this is what the people used to call non-linear. Okay, so here also it is Xi by Xt and here it is E0 by EI. Got it? So here they are using the factor called Rm by Rp. So this Rm by Rp, which is nothing but what, because of this resistance, because whatever the component you are connected already, I am just connecting some internal resistance. So because of that my potentiometer is getting loaded. So because of this loading I am not getting a linear relation. So finally my potentiometer is used for measuring displacement. That was the main application of my potentiometer, displacement measurement. And also it will divide the potential in a ratio determined by the position. So this is displacement we are calculating because of the sliding nature. So just I would like to explain in a circuit. This is your Vi, okay. So your potential divider means it comes like this. So we have a sliding contact point. So out of this, across this, I am just going to calculate my output voltage. So positive and negative, and the total resistance I am just indicated as Rp. Okay. So above the portion of my sliding and below the portion of the sliding, I am just going to mark R1 and R2. So how I can find out the value of my V0, P0, which is equal to Vi, that is my input voltage, into R2 divided by R1 plus R2, because these things you all know, this is called voltage divider rule. Okay, maybe in the first year itself you would have got this point. Okay. So this is what my voltage divider rule. So whatever the loading or unloading, there will be an error. So the error which will be reduced only because of my input resistance, that is my Rm. So if it causes a nonlinear relationship, that is what this graph shows. If it shows any nonlinear characteristics, then the output and the input voltage, they used to calculate it, that is for error nullification. I can go for the expression E max, which is equal to 15 into Rp divide Rm. That means whatever the internal resistance the people going to use, that should be the multiplication of 15. That means that much amount of factor when you are multiplying, then automatically the error get eliminated. So what will happen? Automatically the nonlinear characteristics, the nonlinear one get reduced. Okay, that was the advantage when you are using this particular expression. Okay, so this is how your potentiometer is working. So this is the voltage divider arrangement. Then we would like to know what are the advantages and the disadvantages of your potentiometer. So when you comes for this advantages point of view, it is inexpensive. That means less cost, then simple to operate, and the efficiency is very high. Then it is useful for measurement of large amplitudes of displacement. Larger amplitudes of displacement. So that was the main advantages of your potentiometer. It is inexpensive, then it is simple to use, that means simple to operate, efficiency is very high, we can able to measure a larger amplitude of displacement. Then what are the disadvantages? Because whenever you are going for any devices, there will be an advantage as well as disadvantages, right? So the disadvantages, they require large force because the whole action is depends upon your sliding contact, right? So it need a large amount of force, that means it requires large force for the movement of force to move their sliding contact. That was the thing. The next one is the sliding contact will get contaminated because of so many movements are going to happen. So because of that, your sliding contact will get contaminated, so we have to use carefully. So the transducer is, we can't use it for larger movement, only for few moments you can able to use. So this is very, very important. Okay, so these are, so in this class we have concentrated on what is transducer, what are the different types of transducer, what is resistive transducer, how they are measuring the displacement using your part which is nothing but voltage divider, or we can call it as an potentiometer. Okay, thank you for concentrating. Thank you so much.